Testing, 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 louder. All right, what about now? I think that should be. All right. So these other parts of the pipeline here. Okay, and we're set to go. So welcome to another Hupo stream. Today we're going to be looking at some programming. We're going to be doing a little bit of Python for computer vision. Specifically, what we're going to try to do is we're going to try to use the LiT, L-I-T. This is a model that we were reading about a couple days ago. But they have this nice little collab, and it's basically a kind of like clip where it basically has an embedding space that you can project text and images into, and then you can effectively do kind of a one-to-one mapping. So I kind of want to make like a zero shot image classifier, image segmentation model out of this. So I'm going to make a little Python script that kind of turns this from a collab into something that I can just run on my computer, make sure I have all the dependencies, and potentially put this into a Docker container. So go ahead and get started. First thing we're going to do is we're going to open up our terminal here. We're going to go into the dev folder and the Betterer folder. So the Betterer folder is a folder that you guys can access. It's a repo here, Hupo Betterer. This is where I put a lot of scratch work and little tiny mini projects like this before they're upgraded into an actual full-blown repo. So go ahead and use this if you want, and you can find all the code there. So back to here, let's make a new directory here, and we're going to call it LiT. Go into LiT, clear, and we're going to also make a Python virtual environment called LiT in order to Python activate LiT, Python or pyenv activate LiT. So you can see here that we now have this terminal shell is in the LiT Python environment, which means that when we pip install all these different dependencies here that we're going to need to install, it's not going to overwrite our dependencies in other Python environments. So first thing we're going to do, let's go ahead and put this in. This pip install, see what that actually installs. Okay, so first thing we're going to do is we're going to cancel it, and it has this little Q here. That Q means -quiet, but we don't really want it to be quiet. We want it to actually tell us what it's doing here. All right, so it's installing all kinds of stuff here. It's TensorBoard. What else do we see here? We see PyYAML. What else do we see? More TensorFlow. We see Matplotlib. Pandas. We see JAX. JAX is effectively like a TensorFlow. It's a Python or deep learning framework. 2ML. This is actually kind of like a little 2ML file. These are starting to pop up in all kinds of repos now. It's kind of like a 2ML. 2ML is Tom's obvious minimal language. 2ML is not meant to be a data serialization format like JSON or YAML. It's intended to be easy to read and write, so kind of what it looks like. Right. You store information in it, and people use it to store like environment stuff for CI/CD pipelines, I think. Okay. So now that we have our little folder, we have our Python environment, we have the installations there. Let's go ahead and run Copilot here. So, or not Copilot. VS Code, of which one of the purposes is Copilot. So we're going to make a new file in here. And we're going to save it as a just run.py, I guess. Zero shot. Call it zero shot.py. So first thing we need to do is down here, we need to change it to the LiT Python environment that we created. Now it's in the LiT Python environment, and let's go ahead and copy paste these imports. Control B, that. Here, zero shot classification, LiT, using natural. Okay, so before we even write any more code, let's actually go ahead and run this file here. And we're good. So what I wanted to check there, one thing you can always do is you can basically, let's see, check if available, jax.devices, print. F string. Okay, so no GPU/TPU found, falling back to C. So I do have the better repo. See, this is why it's useful. Go to better. I think in the JAX example here, I do have code that checks the GPU. Advanced tutorial 1. Yeah, here we go. What hardware is running? So let's go ahead and run this. Okay, so found device 0. There's one device, and it's how to install JAX or for maybe the reason this is CPU is because they just want this to run on these collabs that run on cloud instances that are almost always don't have a GPU, just because that. So let's just hit a name. So we'll start with that. And actually, why don't we also, very top, port arg parse, parser, arg parse, parser dot add argument. We're eventually going to need a image directory. Default. Okay. And let's arg sequence. So we've just added a little bit of argument parsing so that when we run this script, we can pass specific arguments. So name for name in models.modelconfig. If name starts with lit. Okay, so in VIT JAX, we have this models, actually click on here, variety of different models that are stored here. And we specifically want models with LiT model. So okay, so I think the way that we're gonna want to do, so need some kind of model name. All right, there's gonna be different ones here. Go ahead and copy that list here. And then let's look at this code here. Let's make this a little bit bigger so you guys can see better. But basically using this get model, then loading the variables, then creating a tokenizer for the text, resizing images. So this is kind of like a image processing pipeline, and pre-processing op for use in the TensorFlow data set pipeline. All of that. Let's go that here. And leave it at there. Leave it there for now. Okay, so let's load some sample images from TFDS. Alternatively, you can also load these images from the internet or your drive. Okay, so it's creating a dataset object. This DS here, which is a TensorFlow dataset. So load the dataset FDS. For example, this is how you would load ImageNet. We actually click on this, fds.load. No typing on the actual. That object. So let's actually see. What is the type? So you're gonna give it. I thought I had to sneeze there. We'll have to sneeze. Actually, we got what we want here. This is actually the type of the object. It's f.data. Provide that type. So it's a type hint, right? And we don't want to load one of the generic data sets. We want to load a data set from our image. So have batch size, shuffle files, download as supervised. Oh, it really seems like. How is data dir? Data dir directory to read and write data defaults to the value of the environment variable TFDS dir. That otherwise falls back to data. Crap. All we need is data dir. And let's go ahead and clean up our image. So we have this argument called image, right? But image path. So first thing we need to do is os dot path dot and user. Actually, before that we need os.path.expand user, and we're going to expand our image dir. That's going to be a type hints there. And image dir, actually we're going to assert that os.path exists, or if not os.path exists. So actually no, should exist. So if you give it a directory with nothing, what do we want? Maybe not. Maybe that's it. Maybe that's good enough now. All it does is it just point it to an image directory, and it says, okay, these are the images in that directory. Okay. So let's put some image. Put a find a nice about this one. Okay. Got. We're gonna select an area. And let's make a new C into dev Etherum, and then LiT a directory there called one other here. Dev Etherum LiT, and have one shot of Babu. I like this. Select area to grab takes shot. All that 02, and we'll. So now, not have our two images of Boo here. They are relatively. They're 341, 342. They're kind of a weird size, but I think that's good. our pipeline. That, and let's exit out of this. Python 0 shot imager equals. Why don't we actually get the path to copy? This. So run this gate. It's 0 shot with a hyphen, not an under. Hyphen. All right, so the first thing it's complaining about here is that model name needs to be a specific name, not list of names. Models. All model name. Let's say model name. Try one of the little ones, I think. This one. LiT 16S is the smallest one. Try that. All right, it's downloading this model. While that's downloading, we can keep code here. So they load the dataset with 10 datasets, and then they create a list of the images. And then they run this list of images through this image preprocessing function that they defined. And then they plot these. So we're going to need matplotlib. We already have it here. Actually, one thing we can do here is we can import imports. View images. And because this isn't a Jupyter notebook, we need assertion error. Boo images downloads manual does not exist. Create it and download extract the artifact. So I think the problem here is they're using this TensorFlow dataset object to load it, but then they don't actually, when they actually apply, right? Because at the end of the day, the images list of numpys. Image list is just a numpy array. So I don't think we actually need the dataset object. Let's actually just load this into numpy arrays. images, for example, in using Python image library. Or image in os.dir image dir. So for all the images in here, image equals yes. Way to do this. Load image from file to a TensorFlow. Then I don't need the Python image library. They literally use it. Example. IL. Go. NP. I think PIL.open is not going to irate. Opens and identifies a Python file. But the file remains open in the read from the file until you try to process all the images. Here, our image list don't need processing. Probably just load the last image. Local copy. PIL open. Image, no such file or directory. So, image directory. Image file path. Let's actually see what that is. Or we're going to put a debugging trace in here. Run it and it pop up here. inside the for loop. All right, and now let's see what the file path is. Image dir called ImageNet 2012. Let's cd and images. We're gonna okay. There you go. So download. Now we just have the two. Image name. I wonder if OS lister has like quickly. Let's not do yeah, let's not do this. Image file path, which is a string, is going to be this. We're just going to hard code the name. Init. Then we're variable here called image. There. The final image is actually a .end array. Okay, and then here, image preprocessing. It like it takes a list of things, returns a function to preprocess image. Process image. Let's try to just give it one image and what happens. Out of this. Run it. Running it, and we're trying to see if the images are going to properly show. So no such file 00.jpg. It's a PNG. Images must have either 3 or 4 dimensions. So the image itself is weird. Here, actually, what we do is we can go to this collab here, and they can tell you. So the shape of the images that they have is probably HWC, so height width change. So go ahead and put a breakpoint here. Run that. Okay, so images.shape, image.shape. Okay, this is actually a 4-channel image. Why is it 4-channel? That 4. I think there's like an ignore alpha or something. Format. That change. Let's also print the image shape, so we have to bug. Open got an mode. type this in PIL image dot open 3 channel. We need convert RGB. Add back, run it. Okay, so now here's our image shape. That's the correct size. Images must have either 4 dimensions. Then it does require a list. Make that a list of 1. No, like this is our little boo boo. Perfect. Python remove TensorFlow warning. Disable TensorFlow debugging. df.getLogger set level. Make less spammy. See if that solved our issue. Not. Filter out all messages. Filter all info and warning messages. So df-logging.set velocity. Logging. Nice, dude. Not get too distracted here. So save this. We have our image. We've loaded the image. We've put it through the pre-processing pipeline. Now let's go back here. And what are we doing with this? We are showing it, and then we are creating text. Okay. Kind of create the text. So possible classification using natural. Oh. Let's try 3 different things here. We're going to try a cat sitting on a yoga mat, a dog sitting on a yoga mat, and a drawing of a house, something that is very clearly not. Embed both the text and okay. And then here, plt.im show is actually showing you play results. Actually, I kind of like. Okay, so it takes the text, it matrix multiplies it with the transpose of the image. Right, so these are vectors, I think. Let's actually go ahead and but basically these are going to be the more similar they are, the more that product is going to be. So putting that through a softmax, turn it into a number between 0 and 1, which you can interpret as a probability. And then here, the data frame. Problem is this not go in. So let's just put a port E and then we'll run it. All model. Loading the image. Running the image through the model. Now we wanted to see what z-image and z-text are. So z-image is an array. z-image.shape. So it's a 1 by 1024 embedding, right? So it's created an embedding vector from that image. Let's do z-text.shape. That's 3 different text embeddings, right? Because we did 3 different sentences here. So it's created 3 embeddings for each of these natural languages or natural language kind of sentences. And then basically what we're doing with this operation here is we're multiplying those 2 together, right? We're kind of basically, this is the cross product here. So we're doing a cross product, and if the vectors are kind of pointed in the same direction and they're kind of in the same place, then that number is going to be high. If the vectors are kind of very different, then that number is going to be low. So whenever you do this softmax, you're effectively kind of squashing that, and then you're going to get a number between 0 and 100 that roughly tells you how close the image embedding is to each of these 3 embeddings here. That's the prob. So we're going to do continue here, and then we look at probs. The probability is 1 for everything. That is no good. think we might need like a weird print that. Grab an area of the screen. We're gonna take a screenshot of. Let's not do with hue. Street. Back. Or 0. Here, and we are for image name. One file path is going plus the image. That's going to be the image and list of the arrays. And this is start off empty. From typing lists type. And we're going to add our image, and the list is actually what we're go ahead and do that. So that one probs. Run this. Okay, we have our 3 images. Running the inference, creating the no module named Jinja. What is going on? Okay, it tried to these are the probabilities. They're all pretty, but at least they're not all 1 anymore. This pandas table is no bueno. That. Load the data set and create an array of class names. Here they tokenize a bunch of things at the same time. Okay, an embedding function. Compute all image embeddings and collect the correct labels. Similarities. The most similar embeddings to predict label. Cat sitting on a computer. And 2 men in black clothing walking on the street. So we can actually or row in a probs. Probs again. Probs is a right. Probs is a 2D array. So each row is going to represent one image. Yes, it's going to represent one image, and then these are the probabilities for each of the print f. Name list. That here. Create each of the rows here. I for the image. Create probs. And then for T, probability in enumerate row F. Probability that image name list I is texts of T and then prob of 0.2 F. All right, I think that should be good. I think that'll print out 6 different statements here. That we can valid syntax. Right here, we've got a cool sign. Okay. Using the CPU, loading the small model, images, close that out. Embedding the text, it's embedding the images, and we get our final. Probability that image1.png is a cat sitting on a yoga mat is 85%. Probability that one PNG is a cat laying on a computer mat, 15%. So kind of low. Probability that 0.2 is a cat laying on a computer mat, 0.99. Probability that image 3 is a cat sitting on is 2 men in black clothing walking on. All right, so this actually works. Doing good, guys. Got it to work. Do we want to try the different models? I think that's a little bit much right now. We don't do that. How are we gonna want to use one thing that I liked, the idea of perhaps doing segmentation, right? So can you tell me what the different parts or should we just kind of make this more efficient? That's kind of. I think let's. GIT file image embeddings. Make these GIT embed images, and then we'll do the text. And model variable. I don't know if you can just pass that. That actually. I think actually what we want. Images. So a list of paths. List of images. Over engineering. Pass them. Leave this like instead of column. Here, hit F. Tokens. Text. What is out? Applies a module method of variables. Output vars where vars is. What is out here? Let's actually put a here's what the what the hell? Image normalized text targets text out type of out. It's let's do key f string a key and then value dot shape or key value out dot items. So out is 3 by 16 by 384 for text embedded, 3 by 384 by text prelogits. Text logits is by 1024. Text normalized 3 by 1024. Image normalized image. Okay, so it's basically the same thing. It's just raw version stuff. So we don't actually need. Batch of image. Batch. What I don't understand. Shape used here. Out of t times 1. What that little t. Okay, so the T is actually doing a lot there. See the difference before Or we were getting 0.85, so it's kind of like normalizing it. So I think that t is maybe the normal. Go ahead and add that back. Add that out and crash. Why don't we output? Running out of ideas. I'm questioning why I even did this. Like I basically just copied over this. But why don't we do pip free? And we're gonna dump this into file here. And saved models star dot np are going to here are the pro shot requirements dot and then the control p requirements dot txt. Wrap and start. It how to freeze packages installed pip free dash. Now we go back to this. Ref dot txt. there. Oh, there's cross dependence. Okay. Script for 0 dot. Alrighty. A little, but bit. And yeah, that was using LiT, frozen, a contrastively trained language model, kind of like clip. Yeah, you can use classification. That